So for the Visitors Week, the subtopic I wanted to talk about are Euclidean rhythms. And so Euclidean rhythms are all about how beats are dispersed across a sequence's length. And so in Euclidean rhythms, we have two values, a larger number, which represents the length of the pattern, and these are what we call steps, and then a smaller number representing the notes to be distributed evenly across that pattern, and these are what we call our hits. And so no matter how many hits you have, they are distributed as evenly as possible. And so some history on this, Euclid, an ancient Greek mathematician, also commonly referred to as the father of geometry, lived sometime around 300 BCE in Alexandria, Egypt. And so he's considered one of the most influential mathematicians, primarily due to his extensive contributions regarding the fundamental principles of geometry. And so around this time, Euclid developed an algorithm for finding the greatest common divisor of two numbers. So fast forward to 2003, a man by the name of Eric Borglund used the basic idea of Euclid's to tackle some timing issues in neutron accelerators. So now fast forward to 2005, a man by the name of Gottfried Toussaint demonstrated that these same patterns that Borglund created mirrored arithmetic patterns in music. So we have an odd number of hits with an even number of steps. For example, 5 hits with 16 steps. And because 5 cannot be divided evenly into 16, there will be an extra offbeat somewhere. And this is what begins to create syncopation. And so just to reiterate, at its most basic form, the Euclidean method is a method used to distribute numbers as evenly as possible. So to demonstrate this, I have a Euclidean rhythm simulator I found online. And so on the left here, this 4 would represent our hits, and on the right, this 8 here represents our steps. And then you can just begin to layer them. And so this is kind of a basic example of a Euclidean rhythm. So I'll start with this, and then add another, and then I'll add a third, and then I'll add one more. And so that just kind of shows how Euclidean rhythms work and how when you layer Euclidean rhythms of different lengths on top of each other, we see that polyrhythms are generated from that.